Effect of dielectric on capacitance. Initially, you assume that you have two parallel plates. The area of the parallel plates is A and the distance between the parallel plate is D. So, in between these two plates, we assume there is vacuum or air, more or less. Epsilon R value is 1. That is, dielectric constant value is 1. Now, the charge density is given by Q by A. Also, E naught electric field, this naught corresponds to free space, which is equal to sigma by epsilon naught, where epsilon naught is the permittivity of free space, whose value is 8.854 into 10 power minus 12 farads per meter. We know that voltage or the electric field is given by voltage between the plates divided by distance between the plates. Therefore, the potential difference between these two plates based on this condition we represent by, that is naught. That naught means free space. So V naught is equal to E naught into D. Also we know that Q is equal to CV. Therefore C is equal to Q by V. So now we deal only with the dielectric is free space. So therefore we represent by C naught, which is Q by V naught. So this is equal to epsilon naught A by D. This naught refers to free space, permittivity of free space. Suppose, so this is the general case, we assume that the dielectric is free space. Now what happens is, between the same two plates you are introducing a dielectric without any air gap. If that is the case, surface charge density between the plate at the surface of the plates will be either plus or minus sigma p. Keeping this in mind, we have electric field is equal to sigma minus sigma p by epsilon naught, because sigma is the charge density minus sigma p. So sigma p is due to the dielectric. We are subtracting divided by epsilon naught. Now we already know that V is equal to ED. Now E is given by sigma minus sigma p by epsilon naught into D. But this value sigma minus sigma p is directly proportional to sigma, because this is negligible compared to the sigma value. So it is directly proportional. So sigma minus sigma p is equal to sigma by k. That is, sigma minus sigma p is inversely proportional to k, where k is the constant characteristics of the dielectric. Generally, k is greater than 1, because the permittivity of free space we assume to be 1 in vacuum. So for all other dielectrics it has to be greater than 1. So now V is equal to E into D. Now what is E? E is sigma minus sigma p by epsilon naught, but we just now I told you sigma minus sigma p is directly proportional to sigma. So we can write sigma minus sigma p as sigma by k. So that's what is written here in the place of E, sigma by k epsilon naught into D. Now keep this D as it is. Now sigma, what is sigma? Q by A. That's what substituted here. In the place of sigma, in the very beginning we have seen Q by A. Therefore potential difference between the plates is given by Q D by A k epsilon naught. Now C is equal to Q by V. So what you do is, Q is here, move this V this side, so these terms will go that side. So Q by V will become epsilon naught A k by D. Now this can be written as epsilon naught k A by D. Generally this k usually represented as epsilon R, relative permittivity. Okay. So the product epsilon naught k is called the permittivity of the medium and is denoted by epsilon. So epsilon is equal to epsilon naught k. So generally this will be represented by epsilon R, relative permittivity. For vacuum, K is 1, relative permittivity is 1, therefore epsilon will become epsilon naught, which is called the permittivity of the vacuum or free space. So K is equal to epsilon by epsilon naught, which is dimensionless, or you can represent the K relative permittivity as C by C naught also. This capacitance is with respect to free space, whereas this capacitance is due to the some other dielectric in between the two plates. So C is equal to epsilon A by D, C is equal to epsilon naught epsilon R A by D. So in this presentation, epsilon R is represented as K. For example, if we consider for vacuum epsilon R or K is equal to 1, for glass it is 5 to 10, mica 3 to 7, water 80.4 and germanium 16. From this what we infer, if you want to increase the value of capacitance, you must use a dielectric, proper dielectric. Suppose if you want to increase 10 times, what you can do is you can consider glass. If the dielectric is going to be a water, then it is here you can substitute 80.4. If it is going to be germanium, it is 16. That is 16 is multiplied with epsilon naught. So that's all about this chapter on effect of dielectric on capacitance. Hope you have understood this topic. Thanks for watching this video. Nandri.